Welcome everyone to today's AGI Geo webinar series. My name is Leila Gonzalez and I'll be moderating today's GeoConnection webinar, Future Trends in Mining. We're going to be hearing from Lee Freeman, Jim Steele, and Gavin Mudd, and they'll be discussing future trends in the mining industry, talking about workforce supply and demand projections, the futures in metal trading, and developments in sustainable mining practices. And just to give you an idea of the schedule today, we'll be starting with Lee Freeman from Downing Till. He'll be discussing the role of talent with Aspen, Colorado as a reference point. We'll be following his talk with a presentation by James Steele from HSBC Securities, and then closing our presentations with Gavin Mudd, who's speaking from Monash University, talking about understanding the environmental costs and constraints of future mining. And we have quite an international crowd today. People patching in from all over the world, and so this is very exciting. And without further ado, I'm going to go ahead and turn the screen over to Lee. So Lee, when you're ready, I'm going to go ahead and hand you over the screen. So when you're ready, go ahead and take it away.
Thanks for this opportunity to address the topic, and I've got two main purposes that I want to accomplish in this short period of time, and one is to provide a foundation for the next two speakers and then additional discussions. And the second point is to open up and explain further to people the opportunities within the mining industry so that we can increase the breadth of the talent pool that we bring to bear on global mining. And the main topic here that I want to do is that the mining industry is a global business, and from the perspective of most of the producers in the world, they're publicly traded companies, and it's a commercial framework. So we look at the world from a global basis, but we also, and that's represented by this diagram that basically is, I think everybody's familiar with it, it's a view of the world with the lights turned on, and it represents affluence, and it represents haves and have-nots. So a responsibility of the mining industry is to provide the basic materials for society to advance. So there's two issues that come forward then in looking at the future of mining, and one of those is maintaining a supply for expanding the breadth of all of the lights that you see there. The other is dealing with the issues of those that don't have light, and in many cases they have the natural resources undeveloped. So mining then also has a responsibility to not only provide the natural resources, but provide an equation that's efficient and fair in the sharing of the benefits from that. Now I want to start the discussion here with some broad definitions and then focus on one particular example. I'm going to use Aspen. So when we look at dealing with natural resources on a global basis, we can look at it from a very academic sort of standpoint and the definition of capital. And capital, I think most of us are familiar with just the money version of capital, but broader definition defines capital as human resources, intellect, diversity of thought, human institutions, so the ability of organizations to accomplish work with that talent. And then the work that's accomplished comes from things that generate real wealth, and that's mining and energy, agriculture and fisheries, and then the infrastructure that's associated with it. And you see right away in here that in the realization of natural resource wealth on mining, two of the critical elements are people and how people work together. And that becomes the critical issue in looking into the future, is the supply of that talent and the ability of that talent to adapt to the needs. This is a diagram that was put together first by Society of Mining Engineers, of which I chaired the committee, so this is data that I developed. And we're looking here at the number of mining engineering graduates for the last 30 years in the US. So this is undergraduate degrees. We chose to use mining engineering because there's a tight definition of mining engineers, whereas if we used extractive metallurgists or economic geologists, we have difficulty defining the breadth of the discipline. So mining engineers and also petroleum engineers have tight enough definitions that we can use very precise statistics. And what we find is that this is not an uncommon shape for a number of graduates. A lot of graduates right there peaking in 1980 or so with the pink type color there. And that's somewhat universal, well, very similar to the US, Canada, and Australia, similar sorts of statistics, and similar to many of the technical fields with the exception of some of the newer ones like computer engineering and environmental engineering. And what I've done here is plot the peak of graduates, which occurred about 1981, through into the 2000s, and it's continued on that sort of trend. And I've also shown then in blue a commodity price, in this particular case copper. Because as we started to see a shortage of people in 2005, 2006, 2007, it was attributed to the increase in commodity price. And I think what you can see in this graph is that they're just very, very different frequencies. So in order to show them both in the same graph, I normalized all of the numbers by the number of graduates and the copper price in the year 2000, and I show them as percent. Now, what becomes immediately relevant to talent for the world in the mining industry is that the bulk of practicing mining engineers in the U.S., and then you'll see there's similar numbers for Australia and Canada, graduated as baby boomers. And as they start retiring through the course of the next 15 years, which I show there at the top of the graph, retiring the next 15 years, they're going to be replaced by those people that graduated between nominally 1985 and, let's say, the early 2000s. And we don't have nearly enough people because the people that are the baby boomers now are sitting in the jobs and were trained. So we haven't been graduating a sustaining number of engineers since about 1987. So we're many, many, many years behind. And in fact, we're graduating and have for the last 20 years about half of the number that would be the sustaining number. So as these baby boomers start retiring, it represents certainly a global shortage with respect to the talent that's provided by the U.S., Canada, and Australia. Then we look at what are the solutions. So extrapolating this forward, a general statement for the mining business globally, I think, will be simply access to talent. And then I'm going to add to this the idea of a social license to operate. We're going to expand on that particular part. The social license to operate, I think most people are familiar with the concept of triple bottom line. I'll talk a little more about that. But that's as we develop mines in lesser developed places, we have to get permission from those people in one way or the other in order to be able to operate the property. And it's that social license to operate that is going to be one of the great limitations on being able to develop in the places that are lesser developed economies. Now, as we try to figure out how mining fits into the global economy and look forward, I want to use, we have to largely address the legacy topic with mining. And with many of the people in the world, and certainly within the U.S., the concept of mining is a negative term, and it doesn't have a positive legacy. And what I want to do is access a lot of the talent that might currently consider us as a negative business entity and address a topic as to how we can actually contribute more positively. And I'm going to use Aspen, Colorado as an example. And I'm going to use generational changes in our view of Aspen as an indication of looking back what happened, and then we can use that as a basis to look forward. So what lessons do we learn when we pick a place like Aspen, Colorado, which I think is pretty well known as an extreme wealthy ski area. So I'm going to look at Aspen today, and then I'm going to snap back one generation at a time for 200 years, and then look at what was happening in Aspen. And I'm going to look at that in the context of the triple bottom line. The concept for triple bottom line is that when we put a new mine into production, we look at it initially in the context of its economic benefits and its risk and reward. So it's all financial. Sometime later, we added the idea of, is it environmentally compatible in the norms and could be developed in the norms society typically use. And more recently, we've added social. So today, when feasibilities are done by global mining companies, they use the triple bottom line, in which case they don't just look at the economics, they look at the sustainability and the impacts that are environmental and social, even if we don't completely understand all those aspects. So what I want to introduce is the idea is that until relatively recently, mining projects proceeded on the basis of an economic imperative. Then we added environmental imperative, and more recently we've added social imperative, even if we don't know exactly how those things are applied. So let's look at Aspen over the course of one generation at a time. And I'm trying to attract students that would be graduating today from universities, so I use the concept of you as the target. Then I go back to father, grandfather, great-grandfather, great-great-grandfather, and then earlier. And I use Aspen because it's actually a caricature of society. A few comments on Aspen today. It has a population of 6,000 people. It's one of the premier ski areas in the world. It's got some of the wealthiest people in the world. The median income is about $65,000 a year. The average house is about 30 years old. So in that sense, it's somewhat typical of the higher end of U.S. cities. But the average house price is $7.5 million. So it's certainly not a cross-section of the world, or certainly a cross-section of the U.S. So I want to look back at Aspen in these snapshots and watch how it's changed, and then use that as a basis to understand how imperatives within the mining industry has changed. So this particular view is taken of Aspen in 1975. So before skiing was at its height, and the beginning of it being one of the special places to attract the likes of Jack Nicholson and Goldie Hawn and James Taylor that drive these real estate prices up. And you can see it's a beautiful mountain valley. This is the summer. You can see a little white spot there in the middle of the valley. And that's the first year of the Aspen Music Festival. So there's just a lot of recreational type things in the city of Aspen. At this point in time, it's still about 6,000 per population, much as it is today. Taking it one generation earlier, so just after World War II, it was one of the first significant ski areas developed in the U.S. by veterans of World War II who had trained as military people in the Aspen area to later serve with the U.S. Army in the Alps in Europe. So when they returned to the U.S., they were interested in this area, interested in skiing, and basically set the foundation for mountain skiing and mountain resorts in the U.S. At this point in time, the town would be about 3,000 people. One generation earlier than that, Aspen is a high mountain valley. It grew a lot of hay and oddly was the potato capital of Colorado. At this point in time, it had about 700 people. Going back one generation earlier, it was one of the premier silver mining camps in the U.S. And so this particular picture is a horse-drawn cart, and that set of rocks in the back are actually silver nuggets. And they're the largest masses of native silver recovered, to my knowledge, in the world out of any one mine. So it was fabulously rich. At this point in time, the population of Aspen was about 30,000 people, and was the first place in Colorado to have electric lights on the city. So you can see some power poles in the back. So one of the most affluent places in the U.S. today, and one of the most affluent places in the U.S. in 1890. One generation earlier, before the name of Aspen, the town was called Ute City, and it was a trading post. This is a picture that was taken where the trading people had come in trading for land that became then ultimately Aspen for trading goods. So you see the Ute Indians here. One generation earlier, and for thousands of years earlier, it was indigenous people. So the topic then becomes, what do we learn about Aspen, or what can we look at Aspen relative to global mining today? And one of the things I would offer is that you can look at these photos, is that it's one culture overprinting another culture systematically. It was a indigenous population culture overprinted by a mining culture, overprinted by an agricultural culture, overprinted by a recreational culture. And the questions then that we ask today is, what do we learn from that? And what rights and responsibilities does any culture have when they go forward with their own economic imperative to the potential detriment of the pre-existing culture? And so when we show the triple bottom line here, I'm showing that we began to understand mining with Rachel Carson's book in the late 60s, so it becomes something that we optimize our decisions to. And with the Rio Conference, we began to understand and more deeply do research on the social responsibilities of overprinting cultures. So today, when we do development, and we are somewhat condemned in our process based on our legacy, that legacy is a result of operating under an economic imperative where today we understand that no culture has a right to overprint another culture, and we're struggling with trying to find that balance. So in essence, we're looking at a revolution in how we proceed, even if we don't know exactly how to do that. So what I'm trying to do here is address that legacy topic in a very positive way, because mining has a responsibility to society, and mining wants to attract not only more numbers, but it wants to attract people that will see mining as an opportunity to better serve social issues and societal issues in the supply of metals. Now what we see then in these two red lines on the right-hand side of the diagram is that 50% of the currently practicing mining professionals in the US, Canada, and Australia will retire in that time frame. So it isn't as if there's going to be a revolution. It's going to be those of us that are the baby boomers handing over the reins to people that grew up under all of the aspects of an environmental imperative, and our significant part of their career has been influenced by the social imperative. So they're going to be looking at and inheriting the responsibilities for the development of mining going forward. So in sort of wrapping up here with this concept that it's an accepted view that the future is uncertain, and the best indication of the future is past outcomes under similar circumstances. So when we look at something like the history of Aspen and we try to look forward and we say, how are we going to anticipate, using Aspen as an example, would never have guessed that there would be 4 fundamental revolutions of one culture overtaking another to end up with an end member that's Aspen today. So the best way to deal with that uncertainty going forward is talent. Having that talent assembled in groups or organizations so that they can effectively use leadership, innovation, and change management. That the schools develop and encourage critical thinking as a tool to go forward, and those aspects are employed in values-based management, which in one sense can deliver the technical prospects of mining, but also mitigate the risk of not following good environmental and social practices, because in today's global world, if you aren't a good social citizen, then the mine gets shut down and there's significant financial impacts to the company. So now with the concept of triple bottom line, we can rationalize being a good corporate citizen with environmental and social into its potential consequences on the financial standpoint. So the biggest, in summary then, the biggest issues we're dealing with within the mining industry is recruiting the numbers of people necessary to go forward with the execution of mining as a discipline, and increasing the breadth of those people to better understand the social impacts on a truly global basis. So I'll close with the same slide that I opened up with, that mining then represents an opportunity and we have a responsibility to go forward. Thank you.
We're going to go ahead and move on to Gavin Mudd. And Gavin, when you're ready, you can go ahead and take it away.
So yeah, it should be coming through now. So yeah, good morning, folks. It's a Wednesday morning over here for me. So g'day, as we say from Australia. I want to try and present I suppose another area that we often don't talk about too much in terms of mining, and it's certainly been touched on by Jim and by Lee earlier, and that's looking at the environmental costs. Because I think, to me, that's going to be one of the really big future constraints, as well as workforce, and certainly I'll talk a lot more about the aspects that that Jim just raised in terms of declining ore grades and other aspects of the ability to resource our future, etc. So it's going to be a bit of a global force, mainly focused on Australia because that's where I've got most of the best data sets so far. But certainly it's a part of a global picture and a global challenge. So I often call these sort of trends as we mega trends, because they really are critical. They're fundamental in understanding where the mining industry has been been travelling over the last 150 years or even more. But also, I think this as Lee highlighted earlier, we need to understand our history in order to actually have a better place and a better ability to really plan for the future properly. So some of these sorts of trends, and these are global, are declining ore grades. Sometimes we don't need to think about just ore grade. We also need to think about the quality of ore, because impurities such as iron, some of the things in iron ore, whether it be silica or phosphorus, or even in things like bauxite. Sometimes things like arsenic in, say, copper concentrate, they can affect the quality of the ore as well as just the actual ore grade of the particular metal that we may be interested in. Now, the other thing, of course, especially over the last 50 years, is there's been a major shift towards open-cut mining for the vast array of minerals and metals that we extract. And associated with that, of course, is a very large amount of waste rock. I'll sort of touch on that later on. But, the other thing, of course, we're seeing, and certainly seeing it in America and South Africa and in Australia and elsewhere, in Canada and so on, is deeper underground mining. Certainly South Africa, the gold industry there is getting down to 4 kilometres deep, and I think that's a significant part of the problems that South Africa's got and why they've got a declining amount of production there. It's not that the ore isn't there, it's just that it's getting too deep and it's effectively becoming uneconomic. So the other thing, of course, is refractory ores and more complex. So, and a good example of that in Australia is the differences between, say, the MacArthur River lead zinc silver deposit in the Northern Territory versus, say, Broken Hill in New South Wales, where Broken Hill was initially mined in the oxide sort of ore in the surface in the 1880s, 1890s. But of course, by the start of the 1900s, they had to move to pretty much entirely sulfide-based processing. And out of that, we developed a new technology of flotation and so on, which was a great revolutionary technology for the mining industry. But when we moved to Mount Isa in Queensland in the 1930s, and then to especially the MacArthur River, each generation of major lead zinc deposits has generally got more refractory and harder to process. And especially MacArthur River. It was discovered in the 1950s, but because it was impossible to process at that time, it wasn't until the 1990s that the project was able to be developed with new technology. Now, as has been touched on already, we are seeing continually growing demand, and that does raise interesting questions about how we meet that demand. Now, one of the things that's also important to understand is the ability to maintain our economic resource base. If we compare a lot of the reported numbers, either from Canada or the US, or Australia, or elsewhere around the world, it's a variable story. Some minerals or metals in Australia have had extremely good success, and others have stagnated. I'll certainly touch on that later. But a lot of these sort of issues all combine. I think we need to understand all of these trends, because to me, the most important thing, and I'm biased, of course, is understanding the environmental cost. As ore grades decline, as we dig up more waste, as we go deeper, as we require more complex technology to be able to process to meet that demand, it's leading to higher energy costs, often higher water costs, more land use impacts and so on, and also a greater cost in terms of rehabilitation. So they're pretty primal, they're very fundamental to understand, and it's very hard to see how we deal with some of these things. So it's, but of course we do need to understand their impact. Now, I mentioned very quickly, this is just Australia, so I'll very quickly sort of go through these. Now, each of these tell a unique story, such as the yellow line for gold, the boom-bust cycle of gold, or the long-term march of growth in copper, for example. But whether we can continue that pattern and replicate that for the next 150 years, like in the same way that we've seen that pattern over the last 150 years, is an interesting question to say the least. Certainly, copper resources, we've got an ability to maintain production at least for the next 50 to 100 years and increase production significantly. Other metals and minerals, it's variable, but it's pretty easy to put some some simple regressions or statistical curves on these and predict out for 50 or 100 years. But I think if we're thinking about sustainability and we're thinking of 7 generations, I like Lee's idea earlier of using 7 generations or 200 years. And you get some rather amazing numbers, to be polite. The next one I sort of mentioned is Aussie ore grades. They're all declining. You see a tiny bit of variability there, but overall the long-term trend is pretty clear. It's pretty much all downhill. Now, associated with that is also the change in the style of ore bodies that we're mining. And copper is a good example, where in the middle 1800s we were mining very rich copper oxide ores right at the surface. And by the end of the 1800s, we'd have to move to sort of larger but lower grade sulfide deposits. So they were more extensive. And then in the late 1920s, early 1930s, because of the depressed copper price, all the open cut mines shut, and there was the only underground mining operated, which then reopened. The open cut mines reopened by the late 1930s, and so on. And there's been a bit of variability since then, based on different projects, etc. But that long-term march is pretty clear, and based on existing resources, and if you look at the grades that are reported in various deposits around Australia, for example, it ain't ever going to go back up. I can't see a scenario, and especially when we couple that with growing demand. The only way to meet that demand is to move to lower ore bodies, lower grade ore bodies, which of course has problems, has challenges. The other thing I mentioned is sort of the changing nature of open cut mining. Certainly the coal industry, if we see sort of black coal there, or black plus brown coal. Also, coming from Victoria in Australia, we have the great distinction of being our brown coal being the most polluting in the world when it comes to greenhouse emissions. We have the highest greenhouse intensity for electricity production in the world, which is not something else many Victorians are proud of. But there's certainly no shortage of brown coal there. But we have to find better ways to deal with that. So again, copper rises and falls depending on the various projects that have been operated over time. So it's a bit variable in some ways, but certainly if you look at nickel, and coal, for example, it's certainly very clear. Let's move on. I mentioned waste rock, and again, a lot of this data is actually buried in an old report. It's not hard to find in reality. It's just hard to actually go through the manual labour to pull it all together. But that's fine. We've been able to get that done now and build up. And a lot of this is only minimum. For some sectors, like say the gold sector, a lot of companies don't actually report the amount of waste rock. To them, they don't understand the significance, whether it's from a production point of view, in terms of economics, or whether it's from an environmental point of view. But again, the trend is pretty clear. It's a very strong exponential growth, especially in some sectors such as copper or gold or coal and so on. Diamonds, of course, we only have one diamond mine in Australia, the Argyle diamond mine, and it's now the open cut is now winding down and moving to underground mining. But again, why is waste rock important? Because of problems such as acid mine drainage. This is a relatively small mine site. It's the old Rum Jungle uranium and a small amount of copper that came out of it in the 1950s and 1960s. Back then, we actually thought uranium was a good thing. We happily supplied the Americans and the British with uranium for the weapons programs of the day. Now, this mine was rehabilitated in the 1980s. About $25 million was spent to address the acid mine drainage pollution that was coming out of that former mine site. And this photo was only taken a couple of years ago, like almost 25 years after that rehabilitation. And we can see from the waste rock dump, this is the dry season. It's up in the tropics near Darwin, the wet dry tropics as we call it. So during the dry season, there should be no rainfall. But we can see the water at the bottom of the waste rock dump there. That's active seepage leaking out of that waste rock dump. That shows we're still getting a lot of acid mine drainage generated and a lot of pollution being caused, being that salt efflorescence, which is quite metal rich and also radionuclide rich. And of course the adjacent finished river, it should be dry during the dry season, but it should not look like this. It should not look like a salt landscape. So now that's not to say that every mine site, every rehabilitated mine site will of course look like this, but it's a demonstration of the fact that sometimes we don't get rehabilitation right. And Rum Jungle is pretty small. It's only several million tonnes of waste rock. And yet the mine sites we're dealing with now, and especially in the coal industry alone, we're dealing with a few billion tonnes of waste rock. So the way I often like to explain things is, if we can get 99% of our rehab perfect forever, and I think that's for any engineer, that's an incredible challenge. That means we're getting 1% wrong. Now that 1% is not just a few 100,000 tonnes. We're talking about tens of millions of tonnes per year, getting assuming that we get 99% right. Now I think that's a significant question, and I think that's why we always have to come back to these old sites and study them and understand how well they're performing over time. Now, I mentioned quickly economic resources. In Australia, we've had a variable picture. Gold, of course, has been one of the great success stories. We've had a long-term exponential growth in gold production, gold resources, as well as in copper. Iron ore, once we discovered the Pilbara, we had a big increase in the 1960s and so on, and it's been a tiny bit up and down ever since, depending on economic conditions. And I think there's potential to push that up even higher. Certainly reported resources by various companies are even higher than the national estimates that are produced by Geosciences Australia. And it's a similar picture for coal, bauxite and others and so on. So from my point of view, a lot of these resources, we can look at sort of their trends and so on, and some go up, some are sort of somewhat stable, and even things like diamonds might go down. But overall, I mean, to me, I think that's only a small part of that picture. To me, one of the most important things is understanding the environmental cost. So I want to quickly sort of segue from the basic production trends into understanding how we can link production to some of these great environmental challenges that we're going to face and we are facing this century. Of course, some of them are related to energy. With peak oil, now here, and we're sort of working out how we deal with that. Things like diesel become quite important, but also our electricity supply in terms of whether it be coal-based or hydroelectricity and so on. Now, this is some work we've done on nickel mining and looking at various nickel projects around the world. So there's a bunch of Australian projects here, Kambalda, Leinster, Mount Keith, and also Murrin, but also a couple of Canadians and one Indonesian project there as well. Now, nickel is two types of ores, nickel laterite or nickel sulfide. And we can see that the ore grades, there for various projects. There's a big difference in the gigajoules per tonne of metal produced between laterite projects and sulfide projects. And that's a big challenge because most of the nickel resources in the world are actually in laterite, not in sulfide. And most of the new nickel projects being built around the world at the moment or being planned are predominantly laterite, not sulfide. Now, historically, because of the Sudbury Basin in Canada, most of the world's nickel historically for the last century has been dominated by sulfide projects. So at the same time, we're dealing with energy security issues and greenhouse gas emissions. We're fundamentally building into the nickel supply a much higher environmental cost supply. So we can do the same thing in terms of looking at CO2, and we see that same sort of picture there. And that's a big challenge. That's something that I think requires some very long-term strategic thinking and planning of how the industry and so on responds. So that's nickel. We can see the sort of the data there. I'll quickly show some work on gold. And this is looking at gold. There's actually a lot of gold mines around the world. And trying to analyse in terms of sustainability reporting, you use a lot of that data and linking the production data in terms of ore grade, the amount of gold produced, to then what the emissions are. What I've also done, and this is based on some more recent work, is analyse the various energy sources that go into various gold mines, including diesel, direct energy, indirect energy. we can see sort of the broad pattern there. That broad pattern in terms of relating ore grade to the say unit emissions per kilogram of gold produced. Generally, it's a pretty clear pattern. Higher grade mines have a much lower carbon exposure, whereas as you go to a much lower grade mine, there's a much greater potential for a very high exposure in terms of say unit emissions. And there's obvious differences. Generally, your hydro, the data shows that we've got a much lower footprint in terms of CO2 emissions compared to say say coal-based electricity sources, and certainly diesel as well. So, but again, a lot of that variability is related to various mine types, whether it's open cut or underground, maybe depth and other things as well. There's probably a lot more factors that actually underpin some of that variability there. But at least it does give us a basis on which to move forward, understanding some of the environmental costs and understanding what they mean in terms of the future as ore grades continue to decline. Right. Now, one of the things that I think will be a big trend in terms of the mining industry over the next sort of few decades is really the shift from digging up raw dirt. The phrase we often use in Australia is digging dirt and buying diamonds. Where we sell the cheap products, so to speak, in terms of iron ore, then we buy back the value-added products in terms of electronics and cars and other imported goods. And I think if we look at Boliden, one of the Swedish companies, Swedish miners, we can see the difference in metal yield between, say, mobile phone scrap and, say, a ton of ore. Now, that's based on the Aitik copper-gold mine in Sweden and so on. So where's the real value? Where's the real opportunities? And I think that's some of the things we can think about as we look forward into the future and try and understand some of these sort of megatrends and how they might actually underpin the ability to maintain supply, security of supply, and continue to deliver the services, whether it be through mobile phones or the infrastructure or our computers, etc. Right. So for me, I think there's a lot of analogies between, say, sustainable mining, peak minerals, or peak oil. It's not always a perfect comparison, but and I think, as we've sort of heard in the first two speakers, there's a lot of patterns of the past, and they've served us well. We've been able to grow our resource base, generally driven unit costs down, new technology has been developed, and we've been able to meet supply and actually develop our communities, our societies, and global trade and so on. Right. But I think, for me, the one thing we have often underestimated, both in North America, in Europe and Australia and elsewhere, is really that environmental cost. And that's understanding both the energy costs, the amount of mine waste that we leave behind, the social impacts, and so on. And I think that's something that over the last 2 or 3 decades, certainly the global mining industry has certainly identified that and has been working to address that. So there's a difference between legacy sites, new sites, and so on. But certainly I think we do need greater recognition that these environmental challenges are only going to get harder into the future, not easier. Right. So I think, to me, that leads me to sort of argue that we need a bit more radical thinking. We need to actually make sure we do link things such as the services that we use our metals and minerals for, and understand that if we extrapolate even for 100 years some of these patterns of the past, they really are unsustainable in the way that we currently mine and process and produce metals. So we do need to actually look at some sort of more radical plans, and I think Boliden is one of those great examples of some really innovative thinking and developing things such as recycling technology so we can continue to meet demand, but provide that demand in a new way at a lower environmental cost. So just like to wrap it up there, but obviously just thank Lila and the AGI and also AIG for facilitating the webinar. And people interested, there's sort of a lot of my work is available. Give me a buzz. And largely just to finish off with a few good old dodgy Australian cartoons, because to me they help explain some of these sort of problems in a very different way as well. So we'll leave it there, but thank you.
Thank you so much, Gavin. We're going to go ahead and open up the panel discussion now. And what I'm going to do is I'm going to be showing the questions as they come in so everybody can read them. So right now we have a few questions. One is specifically for you, Gavin. Is you showed on your slide there AMD. Could you explain what that is?
Yeah, sure. It's acid mine drainage. The simple explanation is you get those sulfide minerals that are sort of buried at depth. You bring them up to the surface and expose them to water and oxygen. The sulfide undergoes oxidation, produces sulfuric acid. That sulfuric acid then leaches out, whether it be copper or arsenic or zinc, a lot of metals that are in concentrations that are very toxic, say, to aquatic ecosystems and a lot of aquatic organisms. So it's quite a severe problem. It's a problem that exists in the Appalachians, in the Rockies, so in Australia, whether it be the arid lands or the temperate areas like Tasmania. So it's a global problem that I think is a very significant problem.
Great, thank you. And to open the question, I guess the next question for everyone here is, as a student, what skills should I acquire prior to graduation? Are there job openings for both master's and PhD level graduates in finance and mining? Which degree fields are best to have to pursue a career in this industry, such as geology, geoscience, general, mining engineering, civil environmental engineering, other ideas? And I'm going to throw that question out to all of you for your answers.
This is Lee. I can take a first shot at it. With respect to openings at different levels, based on work that we've done here in the U.S., it's not uncommon for an engineering degree to be adequate to enter the workforce and to be effective. And then as a person practices more and learns the industry practices, then to go back and maybe concurrently pick up a master's in something that may be related to the original technical discipline or may be related to business. And what I typically recommend people with an engineering degree is work 3 years or so you understand the relevance of the undergraduate degree, and then pick an area of specialization, and in many cases I recommend that they try to do that concurrent with continuing working. I think with science-type degrees then, this relates a little to which degrees to pursue, as a general rule, extractive metallurgy and geology are science-based, and as a general rule, in order to be effective within the industry, usually requires the master's level. As I'm seeing from the industry, the PhD level is not usually required unless a person wants to go all the way to the extreme in the discipline and then become a global discipline expert. So something like rock mechanics would be a place to take that. Some of the extractive metallurgy ones would be to take that, and some of the specializations in the exploration field. And then with respect to the degrees themselves, geoscience in general isn't all that well accepted by the industry companies that I'm familiar with, although there will be an increasing acceptance because of the lack of people that have graduated with a bachelor's of science in geology. There's absolutely, within the mining industry, a shortage of mining engineers, to the point that there's a lot of discussions about bringing in civil engineers that are comfortable with mining and doing cross-training that's concurrent. And then just a quick comment, certainly in the U.S. with respect to environmental engineering, I think we've been graduating a relative excess of environmental engineers, largely because many people that sought their degree over the last 10 or 15 years were particularly attracted to environmental issues. I think understanding the importance of environmental issues going forward as a society. So we have a relative excess of environmental engineers, but I think the increasing importance of that, and particularly with specific areas of specialization, that would be important.
Yeah, I'd just add some quick comments on that. I think in a lot of ways, my approach is, and I think I agree with where Jim and Lee are coming from. I think in a lot of ways the exact degree doesn't really matter. What does matter is you get involved and get out there. Get your fingers dirty. Get out there, get experience, and then do what you enjoy most. And I think a master's is often sufficient. In Australia, certainly during the height of the boom, they were trying to poach people who are still in their undergraduate courses as well in terms of work and so on. So I think in a lot of ways, follow your passion, follow your interest, and get out there and get involved. It's the best way to learn. And then the people with skills across both the science side, the technical side, the engineering side, and the finance side, that's a rare combination. I think that's something that will hold you in good stead for many, many years to come.
Maybe, this is Lee, maybe I could add one other thing. I think all of us agree that the PhD level education for industry isn't necessary in most cases. But probably the biggest single education-related topic that could affect the future of the mining industry, and I would say in U.S., Canada, and Australia, would be the lack of PhDs to teach these disciplines within the universities. And certainly speaking in the U.S., and I think some of the other universities around the world have similar requirements, that to go into the tenure track, you have to do research and publish research at a level that's accepted by the other people within the university system. And that requires a PhD and appropriate research. And what we're seeing in the U.S. is that literally at this moment in time, a third of the positions for mining engineering in the U.S. Are vacant. And we run a great risk of a lack of people to teach the next generation of engineers, and economic geology is actually worse. And there's almost no PhDs coming through the system that are interested in teaching, largely because the salaries are so low. So if someone's interested in getting a PhD within the industry, we're going to some extremes to try to find people that are interested in doing that if they're interested in teaching.
Yeah, I'd support that very much so. Well said, Jim. Lee.
Great. We have actually quite a few more questions. One here is, what practical skills are important for geology graduates entering the job market, such as familiarity with instruments, GIS software, and how much training do employers provide?
I'll go on that sort of first question there. I think one of the things that's important to recognise is sometimes some of the soft skills are actually just as important as your academic knowledge and as your ability to use computers or to use other instruments. And by soft skills, I mean ability to communicate well, both in terms of oral presentations. Certainly if you're looking in sort of the finance side of the mining industry, then the ability to raise funds and so on is critical based on good presentation skills. The ability to write good reports, good papers and so on. A lot of those skills are very important practical skills to have. And certainly I know in Australia that's certainly something that a lot of our employers here, both in consulting and government and companies, look for. Obviously the more familiarity you've got in sort of specific software, I think whether it's various mining software, GIS software and so on, that's always a bonus. But again, I think employers always tend to look at the overall sort of breadth and depth that potential employees offer. So where you've got strengths in some areas, they may be the things that help get you a job and develop your career. And then as you move forward, you can actually then develop new areas or new skills or new knowledge and so on. So I think it's important to make sure you look at the whole picture, not just sort of one aspect such as GIS, etc.
I agree with that, and I think the foundation for all of this is a good, solid grounding in the science itself, and a deep understanding of that, as well as a passion for it. And then I think it's of little value if someone has a deep understanding of something and has a limited ability to communicate it with other people. So writing skills and verbal skills become very critical. I think and I'm a trustee for Society of Economic Geologists, so if I could put that hat on for a moment, the most important, second most important, and third most important thing for geologists people is field methods and the ability to understand rocks and interpret rocks in the field and to have a foundation in mapping. And then things like GIS should be viewed, an instrument should be viewed as a way to supplement that science. But the single biggest lack that we have within the global mining industry is people that are effective in the field of making judgments and gathering the scientific data in a proper way to draw proper conclusions.
No, well said, Lee. I partly agree.
Great, thank you both. And I think what we'll do here is we'll wrap up with this last question about the mining. It says the mining petroleum industry is more visible in Australia than in the USA. The Australian public recognizes the influence of mining petroleum on the GDP of the country. We have a booming undergraduate population of geoscientists and mining petroleum engineers. Although this will not cover the lack of training of suitable numbers in the last 10 years, it is apparent Australian universities will again have to grow geology departments in the next 10 years to make up for the decline in staff through retirement without replacement. And since students will not generally travel to complete degrees in Australia, geology will have to be offered at more universities across a geographically broad area in our cities. Australia's major universities haven't addressed this issue yet. So Lee and Gavin, do you have any insights into that?
Yeah, I'll kick off, I guess, and it's a hometown question for me. I did my undergraduate degree at RMIT in Melbourne, and RMIT for a century had one of Australia's best sort of geology departments and mining engineering degrees. Now, in 2003, due to the RMIT being under severe budget problems, and just cut that whole program. You know, at the height of the start of the mining boom, they just cut that whole program. La Trobe University was in a similar position with its geology school, and it merged the geology school into a broader science program. And so it has less visibility now and a lot less students and so on. And I think it's one of the really frustrating things in Australia, which is I can certainly feel where this question's coming from, is that there hasn't been a good strategic leadership either by some of the universities in question or by government or the industry to actually say, well, where are most of the students actually in Australia? And most of the students are in the big capital cities such as Melbourne, Brisbane and Sydney and so on. And yet Melbourne, as one of our biggest cities in Australia, we have an extremely small amount of geology courses on offer. So where there's some of the greatest potential to train graduates and to get students, graduates into the industry, is where there's a huge weakness. And I think it's a big strategic problem. So I certainly agree with the sort of last sort of sentence there that we haven't addressed this issue yet. And I think even during the height of the boom, there was only one new mining engineering course set up in Australia, and that was in Adelaide. So I think in a lot of ways we haven't learnt those lessons of the past in terms of understanding, to design for the average rather than the boom or bust cycles that we can often see in mining. So it's a real challenge, and I think it's only going to be a continuing challenge. Certainly the Australian government is trying to work out ways that they can improve universities in terms of their performance at the same time as limiting or potentially even driving down their funding. So it's a big challenge, and I certainly don't have the answers, but it's pretty easy to spot the problems.
This is Lee. I broke off for a moment, but I can comment on a particular question. It's certainly from something that's seeing in the U.S. We have a limited number of universities that are teaching at a bachelor's level in each of the disciplines. But we have a junior college system that provides the first 2 years of education, and we're seeing an adaptation within the major universities, including the research universities, to support two-year universities that are calling the 2+2 programs. So the first couple years are done locally, and then subsequent years are when they transfer into the major university. So there may be some ways to in each country with its own restrictions, but there may be some ways to supplement the need by being creative around the topic.
Great. Thank you, Lee and Gavin, and again, thank you to Jim for presenting today. I think we'll leave it there, and we do have a few more questions, but I will definitely forward those to all of the speakers. So, and for all those participants, if you have any more questions, feel free to go ahead and email them to me or to our workforce website, and I'll make sure that we get those out to the speakers.